You know, I have to admit that when this thing showed up at the door and I had to wheel it around on a cart, I really started wondering, what have I gotten myself into? And I didn't know the half of it at that point. If it isn't heavy, put it in a heavy box. And I think that Hickok must have done the same thing, because this box weighs a ton. Well, the oscilloscope weighs a ton too. And you should be thankful this is not smell-o-vision, because this thing, it's got a smell to it. I'm gonna have to clean it right away. It kind of looks like a rat's nest down there, so we'll see what we got, but I'm gonna start cleaning this thing. I've got to get rid of this smell, otherwise my wife is gonna throw me out of the house, so. Okay, I've kind of wiped it off in some of the places, but just now have finished removing the CRT. It's a 5UP1, just like what's on the ICO 460. And the rat's nest of wires does not look as bad as it did before. It's not as bad as I thought. It is filthy, you know, it's still dirty. And I have no idea if there are missing parts in here or not. There may be. There's no documentation for this device. There is one for a 640AF, but I don't think that it's identical. It might be good for going in and balancing everything after you're done, you know, but I did find a drawing on eBay. So I went ahead and bought it. It's dated from 1951 with revisions all the way up to 1954. So where my scope falls within that date range is to be discovered yet. This is a much more complicated oscilloscope than any of the ones that I've worked on before. It's nowhere near like a Tektronix or anything like that, but or a modern day Tektronix, I mean. But it's a lot more complicated than the ICO or the Dumont. So this one's going to be a little bit longer project. I think I'm going to spend a lot of time just cleaning it up and organizing everything and just sort of figuring out what's connected to what and where all of the components are located. It's going to take a long time. I've removed the front base plate on this thing, and you know, so I can really get in here and take a look at some of the passive components and actually locate them. So I'm taking an inventory. For instance, you can see that there's a number of capacitors. Those are trimmers on this switch, and you can see a few resistors in there, and there's even a capacitor underneath it. But those all have to be located and traced out, just to make sure that I've got everything I need on this device. But what I'm finding is that some of these passives, they're bad. You know, I mean, this one has a capacitor, maybe a resistor, a couple of resistors on it, but this one can't even be turned. I've tried to turn this. It's locked up tight as a drum, so it's rusted shut. I've gone through and looked at all of the potentiometers, and half of them are frozen up like that. And there's, I forget the number of them. I think there was maybe 20. Some of those are moving nice and smoothly. Others are a little bit crusty. But I'm going to try to restore the crusty ones, clean them, and do what I can for them. Others, you know, I mean, I wound up, when I tore it apart, some of the parts really wouldn't even come off. So this one I actually had to tear apart in order to remove it, because it wouldn't even come off the faceplate. So I wound up destroying one of them just to be able to remove it. And everything's kind of torn apart right now. Here's the capacitor on the other side of that one that was really bad. This one is not quite as bad, but yeah, I'm sure that that one will buff right out, and we ought to be able to, what's that called, reformat it? Probably not, but anyway, the bottom part is in the best shape of the whole thing. When I look through here, it's actually fairly clean. But on the bottom, there, it shows no signs of rust on any of the components at all. In fact, some of them are labeled, which is a help. Yeah, it's kind of nice in here. Now, there's a few things that are going to have to be replaced, but maybe those tubes are still good. Those two capacitor cans, there's a total of 7 capacitors in there. I'll replace all those. There's a couple of these. I think these are the oil type. On the back, I'll replace those, and I don't think I'll probably keep those cans there. I don't know that I'll want to keep these oil ones, you know. I mean, some people say that those capacitors are good for a lot longer time. Who knows? Maybe they're still good, but if it ever starts leaking, it'll make one hell of a mess, that's for sure. I came across a little bit of writing on here, and I kind of destroyed a little bit of it on the left because I kind of went into it a little bit too hard to try to clean it up. If I, here, let me, but you can still make out a date there that's 2/28 of 52, it looks like. And there's someone's initial above it, and then there's a word that was there that I completely erased by accident. But fortunately, there's some more on this side, and basically what it looks like he's saying is that it's inoperative, and then it's got the same person's initials, but on this one it's dated November 9th of 51. When I went over here, I think that this one said that it was inoperative also, trying to buff it up a little bit. So rather than lose the text, I kind of just taped it off a little bit there. And inoperative looks like MHG, November 9th of 51. And while we're on the topic of interesting notes written in pencil on vintage oscilloscopes, I thought that I would add this one to the mix. This is the shield for the CRT. It's I think it's made out of moo metal or something like that, but anyway, there's a couple of notes that are scribbled on there that I didn't clean off too. I tried to keep those on there. One is RT 55556. Excuse me, I don't know what the significance of that one is. But you can see the date, November 9th again. It doesn't have the year on this one. And then there's a number 3-4. Also, they have a serial number, I think it is, or serial something. And this one shows 715, but it also shows 10210, which is interesting because mine is actually 10282 and serial number 71. 10210 is an interesting number. I'm not sure what that means, but it might be a base number for this particular product, because serial number 71, if you add 71 to 10210, well, you know, you come up with 10281. So it's close to 10282 that I have. I don't know how you get the rest of the way there. I'm just speculating. I really don't know how they go about cataloging their stuff, but I thought that I would show this as something else that I found written on the oscilloscope. The plate on the back of the scope shows the serial number 71 of my 640. We can use the second number, 10282, to help us identify where this particular scope falls in the production run. The schematic I bought on eBay shows an alternate identifier in the upper right corner as Alt-E. Moving to the lower left of the drawing, we find a table that identifies which scopes fall within each alteration. Magnifying the table, we can see that my scope number 10282 was early in the run, within the first group of scopes equipped as Alt-A. Given that this drawing is Alt-E, we should expect significant changes and upgrades to the drawing applied since the first release. Going through the scope and identifying components allows me to not only identify some of the revisions, but also arms me with enough information to construct a 3D model of the scope. Coded components include capacitors in yellow, resistors in red, and coils in orange. Once a 3D model is constructed, I can make screen captures from different perspectives in order to derive pictorial diagrams of the installation as built. Components are identified and labeled, but note that no leads are depicted in the drawings. The perspective of each pictorial diagram is labeled in the lower right. In this case, the perspective is top-rear. And this perspective is labeled rear view from the back of the scope. Each pictorial diagram is laid onto a mask, effectively creating a coordinate system to help us locate components within each view. We can, for instance, see that R88 is physically located at coordinate D3 in the bottom center view. By placing the schematic under a similar mask, we can create a coordinate system for the drawing as well. All that remains to be done now is to create a cross-index that will allow us to quickly relate physical and logical component locations. This is a capture of the capacitor cross-reference. The leftmost column is the component identifier followed by its spec, then the capacitor type and the schematic coordinates. The last two columns are the pictorial view and its coordinate location. Note that a component may be visible in more than one pictorial view. Capacitor types highlighted in green indicate those that are scheduled to be changed out from the get-go. These include all of the paper and electrolytic caps. Those highlighted in blue appear in the schematic, but are not installed in my 640. It makes sense that the unequipped caps fall at the end of this list, given that they are revisions to our earlier design. The resistor cross-reference is laid out in a similar fashion, but note that, unlike capacitor cross-reference, we see an unequipped resistor R12 embedded early in the list. Also note that the orange highlights represent disagreements in the spec between the drawing and my scope. As one might expect, there are many more resistors in the installation than capacitors. Here we see two more unequipped resistors in the list. And we do see 3 additional unequipped resistors added to the end of the list. In all likelihood, the engineers reused the identifiers of components that were eliminated in later revisions, and then assigned new identifiers after those were exhausted. At this point, we can begin to identify where the revisions impacted our earlier design. The goal would be to identify all of the revisions and work backwards to derive an as-built drawing if possible. We can begin by circling the missing capacitors as shown here in red, then do the same with the unequipped resistors we have identified. Next, we want to identify mystery components, which I will define as components that show up as installed in the hardware but have no appearance in the schematic. In this case, these mystery components are all resistors and are most likely vestiges of components that were eliminated in revisions later than Alt-A. The next group of changes includes components where the specs shown in the schematic differs from what is installed in my machine. The ones I'm showing here are all resistors. But resistors aren't the only deviations from spec we find in the scope. Here we see two valves, V11 and V12, that differ from what is shown in the drawing. These are the two metal valves mounted on the back wall, and the difference in spec has a significant impact on the wiring that can be confusing if not taken into account. Finally, we have a couple of differences in the wiring as shown here. For now, I'm not trying to understand these differences, just document them. Note that this is likely not the end of the discrepancies we will encounter during this restoration. We'll almost certainly uncover more as we progress. These are simply the ones that jumped out at me as I was cataloging the system and while building the 3D model in cross indices. As I was going through cataloging the parts on this 640, I noticed that a few of the tubes on the bottom appeared to have this sort of cloudy type look. I don't know if I can get it to focus on that or not, but several of them were cloudy like this. See, you can really see it on that one. One of them just, yeah, that one's really bad. And this one didn't look as bad, but if you look at it at an angle, you can kind of see it. You know, if you look at it kind of like this, you might be fooled into thinking that there's nothing wrong with it. But anyway, I've been into discussion groups enough times to find out, and by discussion groups I mean like the guys that work on amplifiers or radios or, you know, tube test equipment, that when they encounter a tube like this, it usually means that the vacuum is no longer sealed on it and that the tube is bad. And I have a very primitive tester here, this little Mighty Mite, and it's not in the best of shape, but it does the job, and I was able to find that every one of these were failing emission tests. And so I went ahead and tested as many of the other tubes as I could, and that included, and by the way, all four of these are bad. They're all 12 AU7s, but the ones that I tested after this, you know, I had 4 12 AT7s that are in this device, and a 6J6, and a 6C4, and then these two older rusty tubes here. What does it say on there? 6AG7. Out of all the tubes, these two tested the best. And none of the other tubes failed either. There was one that had a little bit of leakage, but it was still in the good range. So yeah, everything else tested fine. It's kind of odd that every single one of the 12 AU7s tested bad. I've always kind of had my suspicions since I got this thing, and I've had it for a while now. I've had my suspicions that it's been dropped. You know, you can tell that there's places where it's bent a little bit, and I had a very difficult time putting this front cover back on it. On top of that, though, I'm wondering why it would only be the 12 AU7s. I mean, all four of them are failing emission tests. Those tubes are bad, so I'm gonna have to order 4 new ones to replace it. There are 3 very large tubes that are in the bottom of this. 2 of them are for the rectifier, and one of them, I forget what the other two. It's an 884. Turns out the Mighty Mite will test the 2 tubes that were in the back here, the 2 rectifier tubes. It still won't test this 884, or at least I can't find anything in the documentation for it. And I put this tube in and it passes one side, but the other side fails. So this thing halfway works, which is not good enough. And then this one, is actually cracked. If you look at it carefully, you can kind of see a crack in it. And I can't seem to get it to focus. See, that crack goes all the way around. So, and that's really, I'm kind of amazed, but it's really, really thick glass on this thing. So, I don't know what happened. I think it's still evidence that this thing may have been dropped. So this one may have just failed over time. But this one, yeah, this one's actually broken, so not much I can do about that. And it failed the test too, emission test. It wouldn't even heat up. At least this one got hot. You know, that one didn't even heat up at all. You know, the handle's broken on the top of this thing, so it could be that that it all busted when the handle came apart. So I wanted to show a little bit more evidence for this thing being dropped. I was kind of cleaning off this case. It's got all kinds of rust and stuff on it, and I'm trying to knock that off because I don't really want to paint it unless I absolutely have to. But what's interesting is that you can see this little dimple right here where it's actually been, you know, something has bumped into it and bent it, and it lines up pretty nicely with this potentiometer on the side here. And you kind of, I don't think you can see it from here, but there is kind of a little bow in that thing, very small one. But you figure that the weight of this box, this case, and the weight of this humongous oscilloscope is right around 60 pounds. So if the handle broke on this thing and it fell off the tabletop or whatever and landed on its side, it might account for a lot of things, including that smashed, if you look way up to the front, you can see a capacitor that's broken into. I don't know if that's blown out or it just got, you know, it got squeezed and broken when this thing dropped. So you got a broken handle, you got a front plate that doesn't line up perfectly, a few little weaves and dips in this thing. You know, the chassis isn't perfectly square. This dimple here, there's also a few things on the bottom that I noticed that are a little bit less, but there's a ding there. So yeah, I'm kind of thinking this thing was probably dropped, and that's why I have so many tubes that are bad, because that's very unusual. I mean, since 1951 you wind up with 6 bad tubes. Yeah, that's not very often. So thought I would run through this. Interestingly enough, when I tested these two big capacitors with my handheld meter, they passed the capacitance test. They were reading right in the neighborhood of 0.5, 0.5 and a half microfarads. So now I got it hooked up to this this analyzer, and you know, this balance wheel isn't perfect, but you can see that it's right around 5. It's that top ring, and multiply it times 0.10 or 0.1 rather, and that gives you the a rough idea of where we are with the capacitance on this thing. Yeah, for this side, you work with this balance wheel in order to find out what the capacitance is. And then this one is the meter that you look at once you throw it and check for leakage. So I have to have this thing thrown down to tell it that I want to do the leakage test. And then we'll throw this. It's been a while since I've used this thing. Okay, there's the this is the insulation test on it, because I think that's what you're supposed to use when it doesn't have any kind of polarity on it. Let's see how close this is going to come back down. Pretty amazing. If this thing, I'm going to look for a date on these, but if this thing is, I don't know, 70 years old, that's pretty amazing. I'm going to set up to test that other one and see how it goes. This one looks pretty good too as far as the capacitance, even on this old balance wheel. It's not too bad. So it's reading 0.5 also, and we'll take a look at these things are supposed to have a shelf life of only so long, but both of them test pretty good. I may even try to run it with these just to see what happens. I've got two more that tested within limits. All the rest of them that I changed out, they were terrible. But I'll set those up. Okay, I've got this one plugged in here. So far I haven't been able to get the capacitance to pull up, but you can see that it's supposed to be, I guess, 8 nanofarads. I don't know if this thing's even capable of going that low. I can get the eye on it, but the reading is, on here it doesn't read so great. So we'll run a leakage test on it anyway. And it goes up and it comes down a little bit, but it only comes down about halfway, so. I guess I'm going to wind up having to replace this, even though I can't find any 0.008 microfarad capacitors. I went ahead and bought 0.01 at 1600. There was also 0.0068, I think it was, and I probably should have got that because it was a little bit closer, but I'll just put the 0.01 in there and see what happens. I don't have too many of them that go as high as 1600 volts anyway. I have another one of these back here. I think I'm going to go ahead and yank it out as well, and tie the other leads back down, put them back in place. And I have an order out for replacements. They probably won't come until about the end of the week. So I'm kind of halfway through replacing the capacitors on this device. You know, all of the paper, the electrolytics, and the wax type capacitors. And one of my biggest complaints about this Hickok, and I don't know if it's this Hickok only or all Hickocks, is that you don't have to hardly move anything at all, and you'll wind up with broken wires. I've had many wires come loose, break off, and some of these I'm going to have to trace back and figure out, where they go. These I cut because I know about that. They go up to that to this potentiometer on the top left, and then I've got a couple more that just broke over here. That for some reason the wires break and come loose. In this case, it was a little bit fortuitous because I'm having to trace the wire back here and then through the other side of the panel to find out where it goes. And what I'm finding out is that, according to the drawing at least, this wire and this wire, they're supposed to be on 1 and 2, and they're actually flip-flopped. So I'm going to have to take a look at the entire tube to see. I'm going to trace it out and see what's going on there. Maybe if they wired it completely in backwards, it might not be much of an issue, but it's not according to the drawing, I can tell you that. So this is the, on the left is the orange-white lead. It comes in and then goes through that 47 ohm resistor, and then it ties down onto pin 2 of tube V3. On the other side, there's another one that comes in. It's a blue and black colored lead, and it ties down. It goes through the same thing, another 47 ohm resistor, but it ties down on pin 7. And then when we look on the other side of the wall, they both come out on this side and excuse me, trace down, and you can see them coming into, that's V2 right there. So it goes from V3 to V2. The orange pair was on pin 2 there, and right now it's the one that's pulled off. But you can tell that this blue and black pair is currently tied down on pin 1, and that's where that orange pair should be going, or orange wire should be going. It actually broke off of pin 2 on this thing. Now I looked at the drawings, and it kind of, I'm not sure whether it really makes a difference or not, but you know, what I'm just pointing out is that it's not the same as what's on the drawing. The leads in question are in the horizontal amplifier section of the schematic as shown here. As we found while tracing out the leads, pin 2 of V2 connects through a 47 ohm resistor to pin 2 of V3, and pin 1 of V2 connects through another 47 ohm resistor to pin 7 of V3. This is actually the opposite of what is shown in the schematic. The issue is rendered moot, however, as they cross the outputs from the V3 plates to what eventually interfaces with the plates on the CRT. So they've accomplished essentially the same thing, but have simply swapped out the triodes within the 12AT7 versus what is shown in the schematic. As I've been going through documenting the differences between the drawing and my 640 here, some of the things I've run across, I've found some shiners and stuff, wires. There's one right there that I need to correct, otherwise it'll be grounded pretty soon. I've also found some components that were bent pretty tight, and they were shorted up against other components, particularly straight across there, those little capacitor resistor pairs over there. But there's one big one that I've been kind of putting off, and now that I've replaced most of the capacitors, I'm kind of in a holding pattern until I get a couple more delivered. One issue that I've been aware of the whole time since I've been documenting the installation that I have here is that one of the power rails is shorted out to the chassis, which means that in effect, it's grounded basically, or if you call chassis ground. And it's been sitting in the back of my mind. I'm trying to figure out, what am I going to do about it? And the time has come where it's like I got a little bit of slack time, so I need to work on that issue. And what I've done is I've found the leads on, it's actually the X leads coming out of the transformer. They tied down here onto V6, which is the one in the center of the frame right now. and then it just kind of loops around across all of these other um, valves all the way across then to the ones on the other side, over to here, and then it finally comes back to the one that's next to it, which is V13. And from V13, when I went over the drawing, you can see that there was a couple of unknown or not capacitors, but resistors there that tied it off to ground. So I'm not sure about what that's all about, but um, that's the situation now anyway. But those two resistors shouldn't take it, you know, be solid short to this chassis. So I should at least see some resistance on it. So what I've done is it's time to start isolating that problem. So I've taken these two leads and unsoldered them from V6 there. And I'm going to get the ohm meter out. I guess I don't have it set up. I'll do that right now and take some measurements. So I've tied it down to the run that goes this way. It's not attached to the transformer now, and the resistance is now 156 ohms, which is kind of, you know, close to what you might expect, because those two bogus resistors, or those two unknown resistors, are 100 ohms and 147 ohms, and there's some wire and stuff like that along the way, so 156 probably isn't too far out of whack. So it would kind of indicate that there's probably nothing wrong with the wiring as it goes through here. Let me move it over to this lead here. Now this is looking back at the transformer, and now you can see that we're under an ohm. So in fact, if I turn this on, it'll detect it as continuity. So what that means is that somehow I've got continuity between the chassis and the transformer leads themselves, and that could mean that the transformer is smoked, which would be bad news. That's a kind of a showstopper, because if I can't fix it, let me look at the other lead. Yeah, that would register as continuity as well. So if I can't fix it, it would be very hard to find a replacement transformer for this thing. I even looked at the drawing that was available on the web for the 640 AF, and it isn't even the same. Yeah, I'm gonna have to unsolder the leads from the transformer, and there's a bunch of them because there's a lot of secondaries in there, and pull it out and see what I can find looking inside. Hopefully it'll be something easy, but I'm just a little bit worried that it might be smoked. Okay, so I got it torn apart, and it isn't that those leads are grounded to this core here. It's that the leads are tied, apparently, I guess they must be shorted, or else they're deliberately tied with a lead that goes to ground. But that isn't the way it is in the drawing at all. But right now you can see I've got continuity between this lead right here and one of those leads that I had. Either one of those, it shows continuity. So that might be a center tap for that, but the drawing, you know, it doesn't show the center tap going to ground. It shows it actually going out and interfacing with a lot of the anodes. It's sort of output tied with you know, another lead. This may be a futile effort here. It all depends on whether or not that thing really is supposed to be grounded, but I'm going to go ahead and put it all back together. It's going to take a little while. To make sense of this, we're going to have to return to our schematic and look at the transformer. In particular, we need to focus on the center tap of the X filament coil. If our center tap is grounded to chassis, it's unlikely to be tied to the output of the choke and go on to indirectly touch all of the plates as shown here. Note also that we already know that the capacitor and two resistors shown in red are not equipped in the Alt-A scopes anyway. So we need to ground the center tap and disconnect its outputs from the drawings. This change has no impact on the output of the choke. It continues to go about its business unmolested. Since we didn't see any half-tapped leads on the coil, we know that this lead is also unequipped. Following it forward, we see that it is ultimately used to drive the internal line frequency on the sync selector. So it can't just be removed, as is the case with the centered tap. The functionality it provides is required. Digging a little deeper, we find that they picked up the X-rail at the end of the daisy chain, again at V13, so that change is noted on the schematic. Returning again to our transformer, we want to prove it out. When the scope was delivered, it came with a blown fuse, which is cause for some concern. We start out by checking the primary leads for continuity to make sure it isn't open, and the chassis to make sure it isn't grounded. We run the same test for each of the secondary coils, but in addition, we verify that each is not shorted to the primary coil. All of these tests turned out fine. I then checked the turn ratio of each secondary coil against the primary, and again, all of this tested out perfectly. Then I went through the process of checking each of the secondary coils against one another. And this is where I found a short between the X filament coil and the high voltage coil. So as it turned out, I have a bad transformer associated with the X filament after all. Arriving at this conclusion involved a lot more fumbling around on my part than this brief summary suggests, but it does represent the net result of those efforts. Ultimately, no more progress can be made until the transformer is repaired or replaced, and finding a replacement for it seems to be an affordable impossibility. I'm making this video while working through the process, so at the time of this recording, the disposition of the transformer remains to be determined. I've decided, though, to make an attempt at a rebuild since I can't really destroy the transformer any more than it already is. But this video is dragging on a bit, even though I've cut out much of what I worked on. So it seems like a good point to cut it off and perhaps start working on a part 2. But before leaving, we can attempt to address a few of the mysteries that remain vis-a-vis the schematic. Recall that in the resistor cross index, we identified 3 that were unequipped early in the list, which we assumed were reused identifiers after the originals had been retired. At the same time, we found 4 mystery resistors installed that we assumed might have been those retired components. We can account for this difference, 3 unequipped versus 4 mystery components, by the fact that I never really listed R55 as missing. As mentioned, it was even labeled as such on the bottom of the chassis. And we can further surmise that R55 was once in the vertical section of the scope by the names of its surrounding resistors, which were R54 and R56. Looking at the cross index again, we see that R117 and R118 were among the unequipped resistors to have their IDs reused. Recall that in the schematic, those resistors were associated with the X filament coil, which we eliminated earlier. It's almost a certain bet that this pair of identifiers was once associated with the two mystery resistors at V13 that terminate the X-rail daisy chain to ground. Assuming that to be the case, we are left with only one unequipped resistor, R12, which would fit nicely as the one remaining mystery component.